when I take my machine learning solution to, say, a product manager, they are telling their management it's self-learning, it'll just keep improving. This is magic right here. And now I have to play devil's advocate against my own solution. I'm like, that's not how it'll work, but still better.
I feel like that's the most common thing ML used to say is, no, that's not how it works. That's not how any of this works. The AI is not constantly learning.
Yeah, I would say that the position of this book, I think, is that your ML system is not well designed unless it is continually learning. And maybe that means almost no ML systems that are out there in the world are well designed. All right, well, welcome to the inaugural meeting of the ML and Production Interest Group of the MLCollective. I am Charles Fry. I'm organizing this thing, but I'm hoping that lots of other folks will help make it what it eventually becomes. I have this nice little inspo board for us. This is my inspiration why I care about production machine learning. There was this long period with all these super cool demos in machine learning, AlphaGo, AlphaFold, successes in machine translation, demos of things that look like they might be self-driving cars soon. That wave of cool demos started about 10 years ago, but in the last 3 or 4 years, there's been kind of this like rubber hitting the road kind of failure of machine learning projects failing, a credibility crisis for machine learning in medicine as people realize these algorithms aren't as magic as they look like when you go up in front of a regulator and try and tell them that your deep learning model is, just straight up magic and has learned the secrets of the universe from X-rays. They tell you to get out of their office and they don't let you market your product. And so there's lots of various ways in which machine learning has come up against a lot of difficult problems as it's tried to go from the bench to the bedside, as they say in medicine, or from the laboratory to the street in the case of self-driving cars. And down in the corner, we have something of the spirit animal of this idea. Sir James Lighthill famously issued a report in the 70s, sort of tamping down the AI hype at the time, the Lighthill report that caused one of the first AI winters. His sort of austere look there should strike fear in the heart of anybody who's trying to oversell their ML algorithms. And this isn't just a matter of smart people know how to use ML and there's just a bunch of people who hopped on the hype train and those people are making us all look bad. Really, really smart and thoughtful people who are good at AI science, at deep learning, at machine learning, struggle with these problems. So Element AI was the sort of Canadian AI mafia's startup to try and build out these technologies. They created a ton of really sick MVPs, minimum viable products, using advances in computer vision and natural language processing and audio and video processing. And after 4 years or so, they had failed to develop any marketable products. And the whole thing kind of was sold for parts in the end in a way that kind of upset a lot of people. And I don't think this is really shade on the people who worked on this project. It was a realization of just how hard a lot of these problems are, going from just stuff that works in a demo on a fixed data set in this laboratory setting, just something that you can actually put out there in the world and people can use. So I think the answer is that there needs to be specific types of research to solve some of the hard problems in productionizing machine learning. But without exposure to production machine learning, researchers won't know which problems to tackle. For me, I was in grad school tinkering on things about convergence rates of neural networks and arcane properties of the loss surface. That was useful research for what it was, but it was super far from what people need in production ML. Part of that was none of those ideas were really being communicated clearly to people working in academic research. I think this is changing, it's improving over the last year or two, but it's something that we should all be cognizant of working on, and I'm hoping that this reading group can help make that happen. 2 organizations are sponsoring making this reading group happen: Full Stack Deep Learning and the MLCollective. The idea is to sort of bring in people who think about productionizing machine learning, think about creating companies and products around machine learning, with people who think primarily in terms of research in machine learning to sort of help aid that communication process. Before we go any further, any questions about these big broad ideas? Comments?
Just a comment. Part of the value of throwing stuff out in the real world is not just seeing what's feasible, but also what problems people actually value, which I think is one of the hardest problems any startup in general faces. But I've seen stuff that people think is kind of easy, but then you have all these edge cases and it doesn't work that great, or you have a problem that you think is really interesting, but it's not actually valued, people wouldn't pay for it. So I think there's sometimes a challenge there though of getting the right type of research funded. It's depending on how long term it is versus short term. And I feel like that's part of like Element AI's challenge, right? Is they were a little more what it could be versus like what right now people want.
Yeah, there's probably a lot of the like short to medium term stuff. I think there now are enough people in industry who'd be willing to like fund that kind of stuff that might work soon, that it's maybe not the best choice if you're an academic, because if it's a good idea and somebody would pay for it, you have to do it as like a graduate student and a postdoc in a couple of months, while a startup is doing it with a team of 5 or more, or a big company decides to do it. For ML applications, I think researchers, when it comes to like researching how to solve a hard problem like 3D sensor fusion, like that's a long-term research problem, good target for ML academics. The kinds of problems I'm talking about here are more about, what do I do when my data is changing because it's coming from the real world as a stream instead of just being this like fixed data set? Or what are the appropriate things to track about a machine learning model? Maybe which norms of which tensors should I track to know whether my model is currently healthy? Those are the kinds of questions that I think fit an academic skill set, are needed by people in production, might not necessarily be done by the like engineers out there in the trenches. Does that make sense?
Yeah, and it seems like a lot of that research is like being done behind closed doors, kind of. To me, it seems like there's such a huge drop off from basically Silicon Valley to the rest of the world. Like even just in looking at like stuff like search and recommendations, the difference between like the grocery store search versus, like Facebook or something, it's so huge. And so I feel like a lot of these problems are getting identified and solved, but there isn't as much visibility to it. Although it seems like that's changing, right? Like with this.
Yeah, maybe you're right. I think there is an increasing sort of closedness of AI research, a lot more secret sauces being developed in industrial labs. Like how difficult of a time, for example, people have had recreating like GPT-3, that training process. People have been slowly figuring it out, but there wasn't there wasn't enough information. Part of the valuation of OpenAI is that they have that information and that know-how. So being able to share that more is also something that having these sort of doing open research on these problems can really be helpful. And of course, if you're a researcher now, you might be somebody who's productionizing ML in a couple of years. So it's worthwhile to get exposure to these ideas as you're doing your research, even if your PhD dissertation or your master's project are oriented to some pie in the sky idea about soft-bodied robots that continuously learn from fused 3D sensor data. Thanks, Daniel. Great. So just a little bit of background on the folks sponsoring this event. So Full Stack Deep Learning is a class, among other things. So it's a class that tries to fill the gap that comes after you finish something like Fast AI's course, or like Andrew's Coursera course, or you take a bunch of linear algebra and stats classes and learn the things you need in order to be able to implement deep learning models. And then you want to move the next step up and think about, how would I make this deep learning model something somebody can actually use out there? Like, I've got something that can detect sign language in images. How do I turn that into an endpoint so that somebody can like take a picture with their phone or a video with their phone, send it over the web, and then I tell them a translation of that American Sign Language sentence into English. That's Full Stack Deep Learning's goal as a course. It's also sort of a broader community. There's the videos for that course are on YouTube. Some other videos are posted on there as well. There's a Twitter where we post content, and a Slack community as well. And I'll share these links and slides in the Discord channel. So Full Stack Deep Learning is this like community oriented around like solving these, like thinking about best practices for productionizing machine learning. And it's a community full of people who are like working at big companies, trying to found their own wildcat garage startups in AI, and people who are just like interested in these problems. But because it's so practically oriented, it's not super research oriented. The other place where we're trying to draw folks is from MLCollective. So I think lots of folks are probably familiar with MLCollective. That's probably where you heard about this, but I have also been recruiting, bringing in folks from other places. So MLCollective, if you're not familiar with it, is this big global open distributed ML research lab that tries to connect folks who are working on things in deep learning, people with ideas, with people with time, people with resources, getting all these people together and creating research. I would say like the core of the community is the Discord forum, and then there's additionally sort of like regular meetings like this one. Some of them are more research oriented, some of them are more like education and learning oriented. That's the background on where this interest group comes from. Let's dive into trying to, be the change we wish to see in the ML research world and figure out what these hard problems in productionizing ML are so that we can do some research on them. What I wanted to do was sort of like start by reading some of the longer form material from the first couple of academics who have started really thinking about production ML problems as a whole and not just sort of like one-off research problems like, oh, distribution shift or, oh, explainability. These are things I've heard that people care about out in industry. So the two people who are, I think, the two most prominent people are Shreya Shankar and Chip Wynn. Shreya is a graduate student at Rise Lab who's been working on open source software and working on problems mostly around monitoring machine learning systems and understanding how you know whether a machine learning system is healthy. And then Chip Wynn is a lecturer at Stanford, among other things, who recently wrote a book and taught a course on the general problems of designing systems in machine learning. So they've got some longer form content. I think like taking the time to read through that carefully, slowly, thoughtfully is the right way to start this kind of research plan of getting folks more acclimated in research to the problems in production ML. The structure I'd planned was to have synchronous meetings every week to like keep everybody on pace, reading through this material at the same time so we can have nice, fruitful discussions about it, but then try and do as much as possible asynchronously. Maybe you're watching this video once it's been recorded and posted on YouTube. So that's one place where we can have where discussions will be available. That's primarily just so that everybody can see what we talk about when we get together. Not everybody can make these. It's in the middle of the night in India and in Japan, for example, and in Australia. Maybe people aren't going to stay up till 4 a.m. to talk about production ML. Not everybody loves it as much, maybe. So we'll try and do these asynchronous discussions on Discord and then maintain kind of like shared open notes on the material that we cover. If you read the chapter for this week, then you've already seen those notes, maybe contributed to them. A couple of folks were commenting. Appreciate that. And I'll also try and post all the material, all the stuff we do, like my slides for this week are also available online and posted in the Discord. These are my ideas based off of looking at the other reading groups that have been run in MLCollective. If anybody has any thoughts or ideas around improvements to this format, I welcome any comments now or later in the Discord.
I don't have any comments with regards to, the structure of what you mentioned, but I did have some questions. So with regards to the material that you mentioned, so right now we're going through Chip's book, right? And so what I just wanted to know is what about like actually working on projects with regards to machine learning and production, because that's essentially how we learn, right?
Yeah, so what I've seen with the other reading groups and with MLCollective is that if you get people together sort of like talking about these problems that they find interesting, eventually a person with that problem and a person with an interest in solving that problem, time, data, and compute, the alignment of these factors will just sort of like happen sort of by chance and kind of like spin off. So I wasn't going to do anything super formal, especially at the start, to try and set that up. But that's definitely something I would strongly encourage, like post about things that you are working on, mention them in the meetings, talk with folks in the Discord, and hopefully we can start spinning out those projects and like maybe create a forum in these meetings where people can talk about the stuff that they're working on, kind of like the research jams that have worked well in MLCollective.
Okay, that would be awesome. I personally mentioned this because I haven't really worked on open source and like collaborative projects which are outside, like an internship or a company. So I'm really interested to do that.
Yeah, I do think we could end up with a best practices GitHub repo, for example, like a cookie cutter GitHub repo would be cool if we end up with strong opinions about how these tools should be like set up and integrated with each other.
Honestly, even tutorials on how to use these tools, even if they might not be the best tool, would be helpful.
I think doing some tutorials would be great. I have plans through Full Stack Deep Learning. I'm planning to do some streaming of tutorials, sort of like walking through tools like Great Expectations and Dagster, DDC, like all these things that are out there, playing around with them and seeing how they work.
Okay, cool. Thank you.
Yeah, great suggestion, Sambhav. If you have any other suggestions, drop them in the Discord. We can talk about them, figure them out. I think we're going to end up basing our decisions on what people are excited about. For example, it seemed like people were like really excited about reading this ML systems design book by Chip Wynn that won our first plebiscite by a pretty big margin. It's this O'Reilly book, Designing Machine Learning Systems, that it's trying to cover pretty much all the things that people think about for ML systems design, basically apart from algorithm design and apart from picking your architecture, choosing whether you're using XGBoost or deep learning. Basically, everything apart from that is part of the remit of this book. So thinking about your data and how you are getting it and how you are providing it to your models. Is it in a database? Is it in Amazon S3? Like those sorts of like fundamental plumbing and engineering questions, all the way up to why these machine learning systems tend to fail when they actually, like when the rubber hits the road and they're out there serving predictions and generating outputs for users. A pretty full stack machine learning systems design book. So I'm excited to work through it. With all that done, let's dive into actually reading the book. Maybe if somebody wants to give their high level impressions of this first chapter.
Yeah, so I can go. Yeah, so for me, I think the chapter, I briefly went through it. And so it explores a lot of the issues that, people when they come into production, they face. And so they mention issues such as this. So like, I think the main issue that I think a lot of people overlook is that in production, your priorities change as opposed to research. I think in research, you're looking towards more of what is interesting and more towards the modeling part. Whereas in production, I think your priorities are more towards what the company wants, what are the business needs. And I think there's a lot of focus that is put on data. So in research, data is like pre-processed, it's pre-prepared. And so one of the problems I worked on, it was for an image-to-image translation problem for satellite imagery. So converting optical data to radar data. And during that, we had to collect our own data and actually went through the whole process of data set creation. And there's a lot of challenges, data cleaning and understanding what to clean in the data. And I think one of the biggest challenges that I'm not sure if it's mentioned in the book or not, but I think there are a lot of issues that arise in machine learning due to the context or the area which it's being applied in. So for example, for remote sensing imagery, like you normally want to normalize your data, right? Like for normal images, you have images between 0 and 255. You want to normalize that, you divide that by 255. But in a lot of the cases, so for satellite imagery, there's no bound as to what the data ranges can be in between. So, just a very simple example is how do you normalize that, brainstorming that part? Like what part do you put your threshold at? And if you put your threshold at that point, does it actually cut off relevant information or anomalous points in some cases? So that questions like that are pretty important in production itself.
Yeah, Sambhav pointed out that there's a lot about the differences between ML in research versus production. That's kind of this middle bit of the chapter here about your instincts from research versus your instincts in production. So we can talk about that in a lot greater detail. And I think there's a little bit of stuff about data, but we haven't gotten, I think, into enough detail that we'd be talking about the problems that Sambhav mentioned about how do you do your pre-processing? How do you make sure everybody's using the same pre-processing? What would it mean to detect that my pre-processing is broken? All of those questions I think will come up when we get to the relevant chapter on data engineering. Any other high-level impressions?
Yeah, I had one thing that I sort of saw as not exactly missing, but something that jumped out to me was, so it's talked about the foundation, right, to implement machine learning in production, kind of how important, good quality, structured data is. And then it's talked about how, the data is constantly shifting, right? I've seen that at work where I work in the recruiting space, and we had a lot of customers that were in the kind of technology space. And then we started to have success in the healthcare vertical, and the types of data we're seeing and the skills for search and that kind of thing are very different between those two domains. So I've seen that. But the other thing I've seen more in the startup space is where your data comes from. I feel like a lot of in academia, it's just kind of assumed like, well, we have data. And even in larger orgs, you have this, well, let's see what's in the data warehouse, or let's see what data we have. But I've started to see, I feel like, more products designed around how do we like collect data, or what's the right way to model this. Like the canonical example is probably TikTok, where they literally design the whole product to maximize the quality of like data collection. But I've even seen that at work where we've made decisions about, like, for search relevancy, how to measure it, you know, like click-through rate versus dwell time versus downstream stuff. And so I feel like it's touched on, but maybe briefly.
Yeah, definitely. Yeah, the importance of data has become, it's something more and more people are talking about, enough that there's also a contrarian anti-data movement from folks like Judea Pearl and Gary Marcus, who want to sort of bring us back to these more like structured symbolic models. But yeah, I think we'll definitely cover a lot of that in, I think it's chapter 3 is the like really data centric chapter. And actually chapter 2, which we'll talk about next week, is a quick refresher on like databases, streaming data, and those organizations. So when Daniel said data warehouse, you weren't entirely sure what that meant, then in chapter 2, we'll talk about data warehouses, data lakes, data lake houses, and all the other kinds of technologies people use to like organize things in production. That's definitely something that's been really eye-opening for me over the last 2 years since leaving academia. It's, you know, it's no longer just like an API endpoint for something like ImageNet or just like tensors stored on disk. People are interacting with these like database systems that provide the data to them. And like what is easy, what is hard, what is like a natural fit, which problems arise in that case are very different to the like tensor that fits in RAM sort of style of a lot of ML research. Daniel also mentioned structured data, and I actually wanted to just dive in on that point a little bit. Most people think of structured data, they think maybe of like strictly tabular data. That's, you know, it's not images, it's not video or NLP. It's like it's a, you know, a table like you'd find in a database where each column means something different. It's a feature, like a feature calculated from some user's behavior or logged by some process or what have you. It's like looks more like what you would find in a Kaggle competition than what you would find in a like PyTorch blog post. That kind of structured data definitely is super popular in production, more popular still because it like kind of dates back to even before the deep learning revolution with these more like tabular focused algorithms like tree-based models. That kind of structured data is very common in production. Like every business has some of that data if they have a well-instrumented software stack and a well-instrumented telemetry for their business. So that makes it super, super popular. But you may be thinking like, I'm a deep learning person. I care about unstructured data. I care about like big fat tensors full of floats, not tables. But even in that case, I think the kind of structure of data that Daniel was mentioning is still there, in that when you get your big fat tensors, they're aligned with things, like they're aligned with the labels during training. So you've got like an alignment that says this unstructured tensor over here is related to this label, it's a cat, right? This other one is related to this label, it's a dog. And that kind of structure in your data actually gets much more complicated in production than it is in research. For example, you may not know this, but like the original MNIST data set has identification of who wrote each digit. And that's been used to create these like different versions of MNIST, for example, where you can pretend you're doing federated learning, pretend like you've got 100 different users, each one submitting you their handwritten MNIST digits. And so like there actually is additional structure to a lot of these data sets that we have. Another example would be the Wilds data set of distribution shifts, was built out of a lot of other existing data sets that people mostly treated as like a big fat block of data by including this metadata that provides additional structure. So that kind of structure in your data becomes super, super important when you're not just trying to make the loss go down and the accuracy metric go up so that you can demonstrate that you've made an algorithmic improvement. Actually, the people in sort of like fairness and transparency research have started to make more use of that kind of metadata. Federated learning is another place, people studying distribution shift. Anyway, so research is starting to take more advantage of that kind of metadata and structure, but it's something that you'll find out on, before you even put out version 1.0 of your algorithm in production, you'll need that kind of structured data. All right, if there's no more high-level comments, I think Yeah, we've got about 20 minutes left, so I want to just grab some of my highlights from this, and we can bounce around. If you see a section that you really wanted to talk about, go ahead and shout out. So there's a section on thinking about how to define what machine learning is and sort of like explain what it is. I think we could spend a lot of time bite shedding the definition and sort of like trying to figure out what the exact right definition is. So I'm going to resist that temptation, which is very strong for me. Aman, who I think is here in this meeting, had an interesting point about this comment or this area in a section of the chapter where Chip is explaining when machine learning is a really good choice. She says one time when machine learning is possibly the right solution for your problem over a traditional software solution is if the patterns are constantly changing. So email spam classification has changed over time. There are different types of spam now than there were in 1997, and all kinds of things change over time is basically is a ubiquitous feature of data created by humans as humans change over time. You've also got like changing weather patterns, changing climate. If you're using that satellite data, all of a sudden, if you had a robot out in the real world using machine learning in 2019 and it didn't know how to deal with a person wearing a mask, that's a problem you need to solve in 2020 pretty fast. So Aman, if you wanted to maybe pipe up and talk about your criticism of this section or your thoughts on this section.
Yeah. Hey, hi everyone. Yeah, I think not really criticism, but a couple of points. One is that even if they're not really changing, sometimes they're just too complex. I mean, for it to be encoded in rules, and and if they're not changing, then maybe you're done. If you sort of build a machine learning solution, that never really happens. But if that's true, but if they are changing, I guess as you responded, it's handled later. But I mean, machine learning without controlling for those changes, I mean, your models are not going to work anymore. So, I mean, you have to either have an implicit way of getting feedback and retraining, or doing it explicitly, or a combination of both. I guess that was not very clear to me from just reading this section. You might get the idea that if things change, machine learning just keeps working and there's nothing more to do there.
Well, I think you're right, but just to play devil's advocate a little bit, I'm going to try to push back a little. So I think something that's like driving a lot of value production in like search and recommendation, for example, is content representation, especially like you're talking about with kind of unstructured data, images or text. And I think that's one of the things that makes like modern ML and prod so complicated, is that you tend to have these like interconnectedness where you have some sort of content representation and then downstream use cases. And my thought process is like, you're right that you have to adapt, let's say like the content representation. Well, no, I guess, you know what? I can't even really devil's advocate this. I think you're right. I just feel like this is the type of thing that works best, right, for dealing with that sort of thing. So it's sort of like, yeah, it's bad, but what's better?
No, yeah. I mean, one of my kind of, I don't know, it's almost a peeve when I take my machine learning solution to say, I don't know, a product manager. They're like telling their management it's self-learning, it'll just keep improving. It's just, this is magic right here. And now I have to play devil's advocate against my own solution. I'm like, that's not how it'll work, but still better. Trust me on that.
I feel like that's the most common thing ML used to say is, no, that's not how it works. That's not how any of this works. The AI is not constantly learning.
Yeah, I would say that the position of this book, I think, is that your ML system is not well designed unless it is continually learning. And maybe that means almost no ML systems that are out there in the world are well designed. I think Chip would include having a manual monitoring and retraining process as part of ML can learn from data and update without having to figure out how the data changed. I think that does count, even though it's not fully automated. Machine learning that continually learns, that would count. But I think she would say that if you just put your model out there, leave the weights frozen, never update them, never check to make sure your model isn't doing something dumb now that everybody's wearing masks and ordering toilet paper, then you have a badly designed ML system, in the same way that if you don't have monitoring of logs or bugs surfacing of issues with your cube pod, then like you have a badly designed software system. Does that make sense?
No, absolutely. That makes sense. I think maybe, as someone who's advocating for a solution like this, maybe if it were automated completely and it could work that way, then, I think someone who's not technically bent would clearly see the benefit and can compare okay, this is manual, this is automated. When this falls somewhere in between, I think it falls on the person proposing the solution to kind of figure out, okay, how much? Now let's talk numbers. What percentage cost? And then you have to get down to that level. And sometimes I feel it would be good to have maybe more frameworks of how to do that.
Yeah.
Sometimes it's just ad hoc. Sometimes it's just some unique thing that you're doing and I ought to do it that way. But
this is one place where there is currently a lot of research happening. Like it's, the problem has been narrowed in scope enough that you can make more, like it's more clear how to make academic contributions. There are benchmarks like the Wilds data set, try and capture what it means for patterns to change and give you benchmarks that you can test your scheme for handling changing data. There are engineering problems for sure about how do I deploy models continually? How do I get something like GitHub Actions, GitOps, like that kind of flow, or Circle CI or Jenkins, these tools people use to build software? How do I get something equivalent to that continuous delivery for ML? Those engineering problems. But for people with a more academic bent, there's KL divergences involved here about like how different are these distributions, statistical problems. In the end, it becomes almost like a meta machine learning problem of learning when your model is failing. And a lot of the same tools that folks in machine learning have developed to build algorithms and understand data actually work to solve this problem. This is a place that's like, I think, a hot research topic now. There was a workshop on it, and I think there's also one at iClear 2022. People are starting to chip at this problem with like pure research.
Nice. Would love it if you could, maybe share some good references on the channel, on the Discord channel.
Yeah. I think the focus is on distributional shift. The other world there, the terms are like continual learning and active learning. Continual learning is sort of like just making sure that your model can learn as data continues to come in. And so there it's sort of the optimization problem isn't that different. There are some differences. Active learning means the model like has a component that learns how to select data to learn from. So like most interesting examples, most difficult examples. Obviously, those are not numerical quantities. Interest or hard are not numbers. So you need like a numerical proxy for these things. That's another branch of research that I think is a little bit less mature than distributional shift, especially the sort of like suddenly COVID happens and things change, or suddenly everyone is obsessed with Fleetwood Mac because of a viral TikTok and like my data has suddenly changed. Those discrete shifts, that seems to be the most mature form of out of these branches of distributional shift research, active learning, and continual learning. But yeah, we got 7 more minutes left, so we've got time to cover probably 1 or 2 more sections. If anybody has any suggestions, you can put them in the meeting chat if there's a section that you think is really good to cover. I like the use cases section. I thought it was like a good overview of use cases. Oh, Daniel had one. Oh, right before the meeting today. Automating manual processes. Things that, enrichment of unstructured or semi-structured data, like parsing a resume, automated data entry. Public Daniel, is that you, Daniel?
Yeah, that's me.
Great. Do you have any comments on the use cases section or these use cases you mentioned?
No, I just think, and Chip hits on this obviously with like a lot of her examples, but I think it's common for us to think about an ML task as like kind of more purely automated. Like, okay, is this fraud or not? Done. What category is this? But I think when you have a production system, you have much more of, or typically you have much more of like a human interaction component. And so a lot of the stuff I focused on personally in the last couple of years is like, how do I give our users more options, more control? And a lot of it is just like, well, how can we best represent the data and provide them tools and that kind of thing?
Yeah, that is interesting. There is a bit more of a focus on pure automation here, or it's presented as though the goal was pure automation of all of these processes. As is mentioned, especially in the like data section, I believe, a lot of people have to do this sort of like fake it till you make it or bootstrapping thing where it's a purely human process that then a machine learning model like slowly automates more pieces of. And maybe the final goal of that is never complete automation, but in the end, some sort of like centaur system, as they're called in chess. A centaur is a computer and a person playing chess together. Getting to a centaur that has superhuman performance is, I think, the goal. When I did some work on deep learning for ultrasound, that was always the goal. The goal was not to like completely automate away clinicians or radiologists or remove the human from the taking and interpretation of an ultrasound, but instead just to like make 100 times more people able to take their ultrasounds, to make them take it 10 times faster, to augment the physician's manual diagnosis process with an automated diagnosis that happens every night to check for suspicious looking ultrasounds that maybe we're looking for something else. Interpretability. One item not mentioned in this section is interpretability. If an enterprise cannot explain why a decision was made by an algorithm, it may face legal consequences or brand damage. This definitely accords with my experience when I was working on the ultrasound project at Caption Health. Interpretability was the thing that I was working on. And this was something that the clinicians were interested in, that the FDA was interested in. I think there is some discussion of interpretability later on here. I think that's definitely a research direction, a well-known research direction, I think, trying to make models more interpretable to explain their decisions here inside the black box.
Do you have like some kind of reading on like the Centaur system that you were describing? Because I tried finding it on Google and I didn't really find anything related.
Yeah,
to what
so
you were-
sorry, it's a specific term from chess. That just means a person and a chess algorithm playing together. The chess algorithm suggests, and then the person like picks the move.
Okay, yeah, I found it now. Thank you.
Thanks, Daniel. Daniel shared a nice little Substack link. So the last section here is some of the principles of making machine learning work in production. And then this is used to like talk about what's going to be in the later chapters. So yeah, there's some stuff about distributed training and model optimization. It's still, these problems are still something you have to think about in production, even if their importance is reduced. What else do we have here? Yeah, experiment tracking and versioning, something maybe you're familiar with from your trying to track and reproduce your own experiments. That becomes even more important on a big team in a big organization. Lots of sort of stuff about what the different chapters cover and how they relate to these sort of like core design principles of making a machine learning system. Yeah, and this nice step-by-step breakdown of what it takes to get a machine learning project out there goes through the chapters basically in order. You have to pick your problem, set up how you're going to get the data, develop a model, deploy the model, check that the model's not breaking, and then check that the model is actually delivering value. So that walks us through the like 9 chapters of the book, walk through these 6 steps here. So it's a nice sort of anchoring point. So what that means is next time we'll be talking about a lot of this data engineering material, sort of fundamentals of data engineering, about databases, just briefly touching on what happens on SQL and on data warehouses and data lakes, and then diving into the concerns about data specifically for machine learning in chapter 3. So looking forward to talking about that with everyone next week.